Hi, kitty cats. Two-time Olympic gold medalist Caster Semenya is back in the news this week, winning a judgment that keeps her appeal to compete in women's sports alive. But what's the real science in this case? Does Semenya necessarily have an unfair advantage, or has she only become the poster child of a misunderstanding of human development for political purposes? In this live stream, I'll go through Semenya's history, some basic human development, and give an informed opinion on some of the claims that sporting organizations and the media have made. As usual, I welcome all of your questions, all of your comments. So let's have a conversation about Caster Semenya. All right, so first I will say this much. Here's my opening spiel. I am Dr. Amethyst Taharic. I am both an author and a podcaster. I discuss identity and gender from a scientific standpoint. If you look at the URL below, you will see more information about me and the work I do. I realize on at least one platform here I'm streaming, it's looking a little funky, and I get that. The website is purplepawclan.com, where you'll be able to follow me on all the social media networks that you would possibly want, as well as read all of my articles and view all of my podcasts. So if you're liking this content, and I realize we're only 2 minutes in here, but if you like this content, I hope you'll consider subscribing at purplepawclan.com. You can get a subscription for as low as $5 a month, but I also will publish other people's articles and podcasts by other, if you want to contribute your work, original work about identity and gender, I encourage you to email me. And once again, purplepawclan.com. There is a contact page there. All right. Let me go ahead and pull some things together here. So first of all, I see Matt is here. Hi, Matt. Thank you so much for the gift. Truly appreciate it. Matt's saying she's back. Yes, here I am. It's been, it's been an interesting month or so as far as streaming goes. So, I'm trying a new type of tool here, and I'm hoping for the best for what it's worth. All right. I want to talk about Caster Semenya. In 2009, if we go all the way back to 2009, so it's been 16 years here, there was a newcomer to the World Athletic Championships. And this person just dominated the 800-meter race. That was Caster Semenya. At that time, she was 18 years old. She was born in South Africa, goes to the World Athletic Championships and just crushes it. Was beating people by multiple seconds. The other thing, too, is that if you looked at Semenya's record over the past couple of years, she had improved really dramatically. I want to say in the 800 meter, it was somewhere on the order of about 8 seconds. An 800 meter, for those of you who I guess are using freedom units, that's about a half a mile. So it's pretty far. 8 seconds is a significant improvement over the course of a couple of years. And so the World Athletics organization at that time, called IAAF, the International Athletics, you know what, who cares? Because now it's World Athletics. So I'm going to go with that. But Semenya had improved so dramatically over the course of a couple of years. World Athletics thought that's the kind of improvement you can only get from, external help. Whether it's some kind of substance or whether it's, something. It's the point. So what they did, because she was so much faster than the competition, they forced her to undergo testing in order to keep competing. Now, I'm going to say it's not entirely clear what all the World Athletics tested, because they did not release all of that. There were some results that were leaked, but I will say this: in 2009, Semenya was cleared to compete again, or was cleared to compete in World Athletics events. And then in 2010, she was actually given another clearing, she was cleared to compete yet again. So after 2009, Semenya competed in the 2012 Olympics, where she got a silver medal. And maybe you'll go, "No, that's funny. I read the story that she got a gold." True. She ended up being awarded gold because there was another athlete who got disqualified, interestingly, for doping. So for some sort of a cheat. So she ended up being awarded the gold, not strictly won the gold, but was awarded the gold in the 2012 Olympics again for the 800 meter, and then went on to win a gold medal in 800 meters at the 2016 Olympics. So why is Caster Semenya in the news? This was just a runner. Who cares about this, right? If you look at Semenya's birth certificate from South Africa, she was assigned female at birth. She identifies as a woman, which, assigned female at birth. That means, some doctor held her up and went, yeah, female, right? This is a guess. It's always a guess. That's why it's called assigned female at birth, as opposed to, some sort of scientific procedure other than, yeah, girl. So she was assigned female at birth. She identifies as a woman, has always identified as a woman. But genetic tests, and these were leaked when the World Athletics did some of these tests. Genetic tests show she has an XY karyotype. And, I guess if you're unsure what that means, that is a karyotype typically associated. So that's chromosome pair 23, typically associated with people assigned male at birth. Further tests also showed that Semenya has a 5-alpha reductase type 2 deficiency. And I'm going to go over what some of this stuff means. But the point is that Semenya, at least in the media, has been called biologically male. But I want to talk about what really drives human reproductive system development. And then I also want to talk, once we've talked about that, is Semenya necessarily better at sports than other people assigned female at birth? These are big questions. The reason she's in the news is because she's filed suits now against World Athletics, because they're not letting her compete. They changed a lot of their regulations I'm trying to remember what all they were. 2018, I believe, 2019, and then 2020. They kept changing these to say, well, we're going to disqualify Caster Semenya. So there's a lot that goes into that. Now, I am going to get to all of that, and we'll talk about it. But let me first actually acknowledge some people. I want to say hello to Penelope. I don't know that I've ever seen you on a live, so hi. Definitely seen you on Discord. Anyway, so that's cool to see you. Hi. So let's see. Let's talk about human development. Human development. Oh, geez, you know what? I don't know if I've missed other comments. Well, it doesn't look like it. Okay. So let's talk about human development. I'm going to take a quick drink. I'm going to restrict this discussion just to human development. I mean, we could talk about biology all day long. All right, but I'm going to restrict this to human development. I don't want to talk about a definition of sex. I do know that I've done live streams where I said I'm not going to debate science any longer. This is just a biology lesson. Think of it like that. That's the way I'm thinking of it. But I do want to make a reminder. So here's my first reminder when we're talking about human development. Every human carries the entire human genome with them. The difference between genetics with an XX karyotype and an XY karyotype is very minimal, especially in comparison to the allosomes. The allosomes are chromosome pairs 1 through 22. According to the Human Genome Project, the human genome consists of somewhere between 20,000 and 30,000 genes on both the chromosome pair 23. We're talking about less than even 1,000 between X and Y together. So it's not a whole lot of the human genome. So that's what I wanted to remind you. Every human carries the entire human genome. The differences in biochemistry between the two sexes that we see, biochemistry is very highly dependent on hormonal balance. And this isn't any organism. It's not necessarily just humans. Biochemistry is very highly dependent on the hormonal balance. So the other thing I want to mention is that every zygote, and a zygote is a fertilized egg, every fertilized egg, because it has the entire human genome, also has the ability to develop both male and female sex characteristics. Now, if you're transgender, this is why HRT works at all. You know, I ended up with actual boobs here going through HRT, because if you change the hormonal balance in your body, you can change the biochemistry and you can change the development of the body, even when you were like I am and started transition at 52 years old. So there's my reminder. Development. Now let's go way back. Jump in the way back machine. Development, human development really begins around 4 to 6 weeks. Okay, development in particular of sex characteristics, and goes into the second trimester of gestation. At this point, what we're looking at is what's called an embryo. It's not called a fetus. The fetus is characterized by differentiation of internal organs, like in particular a digestive system. That's important because it signals the ability to take over some of the operation of the body at that point, the fetus's body, from the mother. Okay, an embryo, on the other hand, has very few parts. An embryo has no ability to metabolize nutrients. You need a digestive system for that. At this point, the mother is doing all the work, all of the work. An embryo is wholly dependent on the environment of the mother's body. The mother provides nutrition for an embryo by metabolizing the food she eats. The mother provides oxygen for an embryo by transporting the air she breathes into the blood that goes into the embryo. The mother also provides development triggers to the embryo through hormones that she secretes. So in this case, as it turns out, reproductive system development, in order for this to begin, it requires a dominant hormone in the mother's uterus. Just to cut to the chase a little bit, male reproductive part development, if you're going to develop male reproductive parts, it depends upon the mother secreting sufficient testosterone. Remember, the embryo does not have these parts, does not have any parts at this point, all right? And the embryo does not develop parts because of what's in pair 23, not immediately. An embryo will only develop male reproductive parts if the mother secretes testosterone. And I'm saying if, right? Why is that? Why would I say if? The reason the mother secretes testosterone is usually because of a gene called the SRY gene. The SRY gene comes from, the SRY gene is named because it's often found on the Y chromosome. It is the sex-determining region of the Y chromosome. There's your S, your R, and your Y. I said often, not always. That SRY gene has been found to translocate. It's the word for it. It has been found on the X chromosome. It has been found on allosomes, pairs 1 through 22. It doesn't always have to be on the Y chromosome. This is an important point. When the SRY gene expresses, so when it actually does something, it creates something called the SRY protein. This is what genetics does. It creates proteins, so you have the SRY gene, SRY protein. Nomenclature is not our strong suit, scientists, okay? It is this SRY protein that the embryo generates, creates, builds, that stimulates the mother to secrete testosterone. Nothing else, okay? The embryo itself does not have any source of testosterone. It's got to get it from the mother. The embryo's got to get it from the mother. Until then, there is no differentiation of reproductive parts. All right, let me check out some comments here. So let's see, I've got Casey. Hi, Casey. Good to see you. Matt says, I got moobs from HRT, which is hotcakes, ramen, and Twinkies. Yeah, it happens. Anastasia, hello. I don't know if it's Anastasia. I'm gonna say whatever. But good to see you too. All right, let me see. Let's talk about the causal chain here. There's a causal chain that's required to develop these reproductive parts. The frequent path is the Y chromosome. The Y chromosome has the SRY gene. The SRY gene then creates the SRY protein. The mother, being irritated by SRY protein, secretes testosterone. Testosterone makes the embryo begin to develop male reproductive parts, but many other paths exist here. That's a long causal chain, biochemically. Anyway, some SRY genes don't always express completely. They may not make functional SRY proteins. Or can they be dysfunctional enough to cause female development in XY karyotype embryos? Yes. If the SRY gene does not create a functional SRY protein, you will get female reproductive parts. Some women, some mothers, are not sensitive to the SRY protein. And that means that they would secrete much less testosterone. Is it enough less testosterone to cause female reproductive development in XY karyotype embryos? Yes. Yes, absolutely. There are some embryos that are not sensitive to testosterone. Can that sensitivity be enough to cause female reproductive part development in XY karyotype embryos? Yeah. Yes, absolutely. But let's go the opposite direction. I mentioned some SRY genes are not located on the Y chromosome. If it's on the X chromosome, if it's on the Y chromosome, could that cause SRY protein generation and cause male reproductive parts in an XX karyotype embryo? Turns out, yes. And there are some women, some mothers, who naturally secrete a high level of testosterone. Is that enough, possibly, to cause male reproductive part development in an XX karyotype embryo? Yes. What did I just do there? 5? That's 5 different paths that we could go down here. Now, how often does this happen? Unfortunately, we don't have very good evidence. We don't know. We don't do a comprehensive genetic workup on every birth. Thankfully, for what it's worth, right? I don't think anybody wants to have their genetics out there all the time. We don't do a comprehensive genetic workup, and frequently, the resulting organism turns out just fine, like operates just fine. Just because you have a different path that the development went down doesn't have to imply the organism's going to be sterile. Now, it could certainly change the Punnett square of probability. I don't know how much, probability or genetics anybody has looked at, but when you have a dominant and a recessive gene, you can make a Punnett square, and it's, 4, right? You either have 2 dominant, a dominant, a recessive and a dominant, and 2 recessive. That's the Punnett square. The point being that in this case, it would be the same. If you had, let's say you had somebody with male reproductive parts with an XX karyotype, they will always contribute XX. And so you're not going to have the opportunity even to have boy children. But the other direction, you could have a human with female reproductive parts and an XY karyotype. You will end up with one non-viable combination. So you'd still have XX, you'd still have XY, but then you would have a YY, which typically is non-viable. So it would change these things. Frequently, the resulting organism operates just fine. And we'd almost never measure this. Because if you're talking about always having girls and 1 out of 4, you might have something non-viable, we don't even notice that. Right? Most people don't bother going to a fertility clinic unless something seems really, really wrong. And typically what we do is we measure deviations from the frequent path. I'm not going to say normal, We measure deviations from the frequent path only when they appear to cause problems. Sometimes we end up with genetic characteristics that are unfavorable for the organism. That could be biochemically, and for what it's worth, it could be socially. There are some characteristics like there are some women with naturally high testosterone who will develop facial hair, and although biochemically that's not dysfunction, socially it could be thought of as that. But sometimes we do see organisms that appear exceptional. And in this case, now we can return to Caster Semenya and her high testosterone blood concentration as measured by World Athletics. I'm going to tell you, I'm a little bit confused here. I'm not seeing comments, and I don't know why that is. I wish I knew, but I don't. This is a brand new tool that I started using here, and I don't know. If you're leaving me comments on other platforms, I appreciate it. And hello. I apologize if this is working kind of funky. So I want to talk about. So I said we can return now. Oh well, Matt's saying I'm not being seen on a different platform. Well, that's fascinating. I wonder why that is. I don't know. Oh, you're not seeing comments. Oh, okay. Well, maybe that's good. Well, hey, people on other platforms, how come you're not commenting? Leave me a comment. Let's see. Well, here's an interesting point. Yeah, so Angel7 here, first of all, hi, Angel, says she just read in a medical journal about PTSD, that as a result of those cognitive occurrences, the amygdala can produce testosterone. So we do have a few ways of making testosterone. Every human body does. The adrenal glands can create testosterone. The amygdala can secrete some testosterone. And then obviously, there are the primary sex glands, the primary sex characteristic glands. So, it's possible to have testosterone. Obviously, women must be able to make testosterone. Otherwise, there would be no men. Because ultimately, as I mentioned, that's the mother's job is to end up making enough testosterone to kickstart that development. All right, so to go back to Caster Semenya, because this is a fascinating case. Caster Semenya has an XY genotype, right? But so do I. But we both have, or I guess in my case, had what appears to be an atypical blood concentration of testosterone. Now, this is where this distinction, I'm going to talk about an intersex characteristic, and what people have called Caster Semenya's condition is a difference in sex development. This is where these definitions begin to diverge. There's not a really exceptional definition for both. An intersex characteristic is a catch-all term. It describes a genotype. So this is the full genetics of an organism. Okay, so not the genome. So it describes an overall genotype that results in characteristics that would commonly be associated with the other sex. Now, these could be primary sex characteristics. They could be secondary sex characteristics. Almost all the time, they're undetectable. They might be the endocrine system. They might be slight changes in biochemistry. It could be a few things, but we know that we have identified on the order of about 1,200, okay, genetic intersex characteristics. The current estimate is that somewhere around 1 in 20 children is born with an intersex characteristics. 1 in 20. Okay, that's 1 in 200. No, wait. Yeah, 1 in 200. Sorry. 0.5%. That's the guess. Not an insignificant number of people. So here we go. I want to return to my reminder. Every human carries the entire human genome, and this is why intersex characteristics operate the way they do. if you have an intersex characteristic and it changes your biochemistry sufficiently, those the genome, your genotype will express just the way it does. And that might mean that you end up with some secondary sex characteristics that would be associated with the opposite sex. But that's why these things happen. Genetics is not perfect, not by a long shot, and does not operate perfectly in any single human ever, nor will it ever. So let me talk about intersex. So in my case, I appear, well, I haven't gone and had like tremendous, really, really hardcore genetic workup done on me, on myself, but I appear to have a partial androgen insensitivity syndrome. The way that this presents, my body was capable of making a tremendous amount of testosterone. Like it was really surprisingly high the first time I got a test. But my body was also, I said, partial androgen insensitivity. Despite my body making a tremendous amount of testosterone, my body was unable to utilize it efficiently. And the endocrine system, the way the endocrine system works, it's a big feedback loop. Your body is going to try to, is the hormones generally don't do the work. The hormones are secreted and it causes other things to do work. So usually the body will try to secrete the hormone until the job gets done, or your body kind of hits its capability of how much testosterone, how much hormone it can make. So despite my body not utilizing testosterone efficiently, my body still cranked out enough testosterone that I developed reproductive parts. And obviously I was capable of reproducing at least once. I will say that. But the reason why this is classified as an intersex characteristic, I never had much in the way of body hair. I never had as much muscle mass, nowhere near as much muscle mass as my father, who had these massive forearms. It was like Popeye. It's the craziest thing. I never have seen anybody with that big of forearms. I don't know why. I don't know why in particular he had forearms, but there you go. I also, you'll notice, didn't lose my hair. When I was 50, I'm 55 now. I didn't lose my hair, but I also couldn't grow a beard to save my life. These are characteristics, these are secondary sex characteristics having to do with body hair, having to do with muscle mass that are commonly associated with people assigned female at birth. That's called an intersex characteristic. Now, Caster Semenya appears to have this deficiency. I called it a 5-alpha reductase type 2 deficiency. This deficiency can actually happen in either karyotype. I mean, it is a genetic condition, and it can happen in either karyotype because it's an allosomic condition. This is a condition and a genetic condition that isn't driven by chromosome pair 23. It's not on the X chromosome. It's not on the Y chromosome. It's on a different chromosome, and there's a big causal chain. Let it go. 5-alpha reductase type 2 deficiency can happen in either karyotype. Usually in XX karyotypes, it's not even observed. It's not noticed because what 5-alpha reductase does, 5-alpha reductase 2 does, it changes testosterone to, okay, here we go, 5-alpha, right? 5-alpha dihydrotestosterone. I'm going to call that DHT because it's so much easier. Dihydrotestosterone. DHT is associated with male reproductive part development. Really comes into its own during puberty, right? So during male puberty, a whole lot of DHT ends up being used because that's part of how all of these reproductive parts end up developing completely. It's how humans end up getting to sexual maturity with male reproductive parts. But I want to point out, we've already talked about the SRY gene. We've already talked about the mother being sensitive to SRY protein. We've already talked about the mother secreting testosterone and the embryo being sensitive to testosterone. Here's one more link in this chain, that you also have to have 5-alpha reductase 2 and generate DHT. All of this is necessary in order to have full male reproductive part development. Okay. Now, Caster Semenya appears to have incomplete reproductive parts. Now, obviously, I haven't seen all of this. I don't know how they determined all of this. This is not information that's like publicly available, apparently. But Caster Semenya appears to have no uterus. She also appears to have testicles, but they haven't descended. So it appears she has testicles inside. Now, that's not obvious just how functional these testicles might be. We don't really know because, again, we can take guesses, but the point is that she has been called. Somebody measured something, and I don't know how true this is. Okay, this is a media thing. Supposedly, she had a blood concentration in the normal range of somebody assigned male at birth. But because she cannot produce DHT, dihydrotestosterone, she did not develop male parts. So that's what a difference in sex development is. So 5-alpha reductase type 2 deficiency is an intersex characteristic in that it changes something that would be to make something appear, but it actually affects primary sex characteristics. That's why this is called a difference in sex development in particular. I don't know why we need two different terms for what it's worth, but also for what it's worth, intersex isn't not a very good descriptive comment or descriptive word. Because intersex would imply that you end up with, well, in between, right? But that's not the case. That's not the case of most of the intersex conditions that have been identified. So I talked about the difference, but I also want to call out a similarity here, okay? Both Caster Semenya and I had, again, for me, high testosterone blood concentration. Both Caster Semenya and I both can't process testosterone in a way that would be considered normal. I'm going to use quotation fingers just because it's fun. And that means that both of us, Caster Semenya and I, ended up with an appearance inconsistent with, once again, normal genetics, okay? Now, I'm not a very good runner, never was a great runner. So it's probably important for us to think about what part does testosterone play in sports performance. Let me check out all of my all these comments here, and how come other people aren't commenting? Once again, I ask the question. All right. So let's see. Angel 7 makes up the point. So because she read in a medical journal that cognitive effects like PTSD can raise testosterone blood concentration, Angel now says by some conservative theories on hormones, anyone with trauma should be banned from sports too. I think that's everybody. I think that's, do you get out of, what was it Jim Morrison said? No one here gets out alive. Yeah, no one gets out of childhood without trauma either. So let's see. Then Matt brings up the point they don't care. They're not about fairness. They're about discriminating against transgender people. I agree with you, and I do want to get there. It's it's a great point. It's a really great point. So as long as we're talking about it, does pure testosterone, does that necessarily give an advantage in sports? Biologically, here's a question. What does testosterone do? It's typically associated with protein growth. And that, is somewhat somewhat vague. Typically, that means higher bone density. Typically, it means more muscle mass. Typically, it means that you build bigger parts. And this is why you have people assigned male at birth typically larger than people assigned female at birth. Not always, of course, right? Because I'm sure we all know a very small man and a very large woman. So why did I use the word typically twice? Typically associated with protein growth. Typically, You have AMABs bigger than AFABs. Use the word typically twice because genetics is a whole bunch of probability. It's not a whole bunch of deterministic biochemical facts. Now, I have more to say about this on the live stream I'm going to do on Tuesday, okay? But the quick point here is that genetics does not define a blueprint. It's not like you lay something down like a blueprint I'm talking about. If you have like a house, you go, well, here's my house, and you just build it according to that. Genetics isn't like that. You can have things like Angel says, PTSD, this is a cognitive condition. Is that necessarily biological? Maybe not. But it does, but it does change biochemistry. Genetics is not a blueprint for your biochemistry. Genetics does not operate the same way every time, even in the same organism, because the environment plays a huge part. And obviously, as Angel has pointed out, cognitive conditions can as well. Hey, it's Siren. Hi, how you doing, boy? Glad to see you. So again, more on this on Tuesday, but the point is that like your environment makes a big difference. That's nutrition, that could be temperature, and guess what? Previous environments as well, because it builds on itself. That makes genetics, from a systems theory standpoint, and this is partly what I was going to talk about on Tuesday, but it makes it both complicated and complex. There are a lot of variables involved, and where those variables go depend upon where they started. And if they change, then you go, again, now you have a different starting point. It's both complicated and complex. So when I use the word typically, that reflects that every human, ultimately, first of all, has different biochemistry. And that different biochemistry, different from everybody else, but it also changes throughout life. Typically also reflects that every human is going to respond differently to the environment. And even if we detect trends in a population, every human is going to respond differently to the entire environment. Again, to remind you, my partial androgen insensitivity syndrome meant I didn't develop much facial hair. But Caster Semenya's 5-alpha reductase type 2 deficiency meant that she didn't develop complete reproductive parts. Here's a sample size of 2. Every human being responds differently to the environment. But my question was, does testosterone mean increased muscle mass and improved sports performance? In my case, no. I have always struggled to build muscle mass. Testosterone could mean, high blood concentration of testosterone could mean increased muscle mass, which may be associated with improved sports performance, only if your body can use it. My sports performance was awful. Still is. It's not gotten better. Caster Semenya's performance is really good, at least relatively speaking. Certainly, really relatively speaking. So, let's talk at least a little bit about the difference between testosterone and dihydrotestosterone. Now, dihydrotestosterone, here's a little quickie chemistry lesson. Now that we've been talking about biology, my apologies, I'm going to go into chemistry. DHT is not an isomer of testosterone. Okay, this is structurally different. Chemically the same, structurally different. That's an isomer. This is a completely different compound altogether. Testosterone is a sterol backbone. It's not that important, but generally you're talking sterol backbones have carbon rings, connected carbon rings, 6-member and 5-member rings. Testosterone has an additional carbon-carbon double bond at the very bottom of the sterol backbone. So while chemically they appear very similar, dihydro means you've added 2 hydrogens. Doesn't sound like that should be much, right? So chemically they appear very similar, but structurally, a carbon-carbon double bond does not move the same way as a carbon-carbon single bond, which is what DHT has. So the Chemically, although they're very similar, structurally, they can be very, very different. And structure, if you took any biochemistry whatsoever, structure makes a huge difference in biochemistry. You may have seen information about D and L sugars. So dextrorotatory or levorotatory. It has to do with whether they rotate light to the right or to the left, respectively. They're D and L. These also have been called S and R for sinistre, and I forget what the R is. Right-handed, who cares? Because I'm left-handed, I don't care. Whatever R is. Anyway, point is, those are isomers. D and L are isomers. They're the same chemically, but structurally, the body typically only works with D isomers, with D stereoisomers, to the point where if you can go and get like Splenda. I'm trying to think of some of those sugars that are out there. There are some sugars out there that are L stereoisomers, and your body tastes it and goes, "Ooh, that's very sweet," but your body can't process it. It doesn't do anything else with it and just passes on through you. That's part of the indication of why structure makes a difference, because it makes a huge difference. So let's go back to testosterone and dihydrotestosterone. Both of these compounds, both of these steroids, will bind to androgen receptors in the human body. And this is how the endocrine system works. You've got these receptors and they'll bond to it, and that causes something else to go on. And I'm going to say again, this is not in XY karyotype bodies. This is in the human body, okay? Once again, we all have the exact same biochemistry as far as allosomes are concerned. Not exact same, but very similar. But DHT on these receptors has a much higher binding affinity. It binds to these receptors much more strongly. And if it binds more strongly, that means it comes off less easily. Yeah, that's fine. The point is that these receptors have a better chance of being filled, and whatever it is that testosterone is supposed to do when it binds to this androgen receptor, there's a better chance that's going to happen. Okay, now I bring this up because, again, an androgen insensitivity syndrome, such as mine, may only be because my androgen receptors aren't very good. Maybe I'll make a whole ton of DHT. I don't know. I don't know what the actual point is. But when you have a higher binding affinity with that, and you have you have a lot of DHT, that makes a better probability that whatever the endocrine system is supposed to do, it will do. All right? In a normal body, let me do that. In both women and men, okay, both XX and XY karyotypes, there's usually about the same amount of testosterone as dihydrotestosterone. Usually these hormones are at very low concentrations, very low blood concentrations, and they're always being recycled, because the endocrine system is trying to regulate something, turn something on and off and back on and back off. Both of those two compounds will get taken out of the bloodstream frequently when they're not necessary. Because like I said, the endocrine system is a big old feedback loop, right? All right. There is one more point I want to make here. Human bodies, when we look at binding affinity, human bodies are capable of using DHT more efficiently than testosterone. Or maybe I should say that differently. DHT is used more efficiently by a human body because it's got a higher binding efficiency. You could have less DHT in your blood than testosterone and get the same effect because it binds more, it has a higher binding affinity. So while Caster Semenya may have a whole ton of testosterone in her blood, that doesn't mean she necessarily uses it. If you look at her record, she had a period where she won a ton of races, but that wasn't always the case. And I want to remind you, her first Olympic gold didn't come because she won the race. Her first Olympic gold came because somebody else was disqualified. The one who did win the race was disqualified. I'm not going to diminish that. It's an Olympic gold, okay? I don't even have an Olympic bronze. So I'm not going to diminish that. But I do want to point that out. She's not always won every race. She had a period where she won a lot. All right, there is one last point that I want to make, and I see I didn't even put the link in there. Good job. But let me check these out. So here we go. We've got, so Matt, now I swear I'm going to get to the idea about fairness or discrimination. Siren, thank you so much for the gift. I truly appreciate that. And Vanessa, hi, I'm good. It's good to see you here too. All right. Why am I bothering to talk about any of this? Like, why is Caster Semenya kind of a big deal? Well, the media, in particular, has used the phrase biologically male to describe Caster Semenya. They are keying off of one characteristic, an XY genotype that Caster Semenya has. She was assigned female at birth. She's not able to reproduce at all. And if you've listened to me even for, a little bit, you know that reproduction is what it is that ends up defining sex. She does not produce ova. She does not produce sperm. She is not able to reproduce. Semenya herself, and actually kind of like this, she uses the phrase, she's just a different kind of woman. And the thing is that biology actually would agree, because what she has is human biochemistry. She's got all the allosomes. It turns out her 5-alpha reductase type 2 doesn't work really well, but otherwise she's a human with biochemistry. But sports wants to disagree. Sports wants to disagree, and politicians want to disagree because she doesn't have the biochemistry that they want. But that's really different. This ends up coming down to politics. It's not science. And so I'll go back to what Matt says. They're not about fairness necessarily, but discriminating against transgender people. Matt goes on to say the thing we point out is that it's hormones that affect performance, not assigned sex at birth. And the thing is that it's not even necessarily hormones, right? Then Matt goes on to say Caster showed us that even hormones don't guarantee wins. Because I brought up my own situation to say I ran a marathon, okay? But I came in like 30,000th place. No, I'm sorry, 19,000th place. I'm not super proud of that. I am proud I finished a marathon, but 19,000th place, it was a little far back. It was out of 30,000. But assuming, I'm not even going to assume, when I was 32, now I was 31 at the time, just under 32. When I was 31, I had the same partial androgen insensitivity syndrome as I do now, which meant I probably had an atypical blood concentration of testosterone in my body, but I still came in 19,000th place. What the hell does that mean, huh? They're keying off an XY genotype, and an XY genotype doesn't guarantee male reproductive parts. It doesn't guarantee that the hormone balance is going to be a particular way. It doesn't guarantee that performance is necessarily going to be better. This comes down to politics. It's not about science. Human biology is what we observe. Human biology is not what we wish it was. And I've talked on and on about this, right? Over and over. I've talked about human biology is not the same as politics. We would never have cared about Caster Semenya if she hadn't gone into running and if she hadn't have won races. If she hadn't gone into it and she hadn't won, we wouldn't even know her name. But her competition and the sports organizations, a lot of sports organizations, and I'm not dumping on her competition here, but the sports organizations, in particular World Athletics, want to imply that because of her biochemistry, she's cheating in some way. But if what we're looking at here, if we have even a name for this, okay, we have a name, 5-alpha reductase type 2 deficiency. We know where the genes are. We know the causal chain in this. This is human biochemistry. How is that cheating? Now, if you go back to her 2012 gold medal, The person who did originally win that race was accused of doping or was found to have doped. So that's, usually what that implies is that you've had blood removed from your body and then centrifuged. So you put it back in and you end up with more ability to mobilize oxygen because you've got more red blood cells. So you can mobilize more oxygen, you can metabolize more quickly. Doping, that's cheating because that's not the way her body normally worked. But this is the way Caster Semenya's body works. If it's just human biochemistry, how is that cheating? It isn't. But humans, ultimately, we want to classify other humans. And we don't want to classify them necessarily for scientific purposes. We want to classify other humans because it gives us the ability to regulate each other. Semenya has been caught in the crossfire of politics, ultimately sports politics. And in our demand, in humanity's demand to have these clear-cut boxes, we're willing to leave biology behind. We're willing to say, who cares what the assigned sex at birth is? We're willing to say, we don't care about hormonal balance. We're willing to say, we don't care if somebody is able to use those hormones effectively and efficiently. We don't care. We're going to leave the biology behind. So in doing this, because as I mentioned, World Athletics, I better cough one sec. World Athletics has changed the rules something like 3 times. 2018, 2019, and 2020, I think. Might have been 16, 19, and 20. It's not that important. But they've changed the rules like 3 times. Have we created a more level playing field? Or what this doing creating a new method of discrimination that's based on purely involuntary characteristics? Now, I'm not going to kid you. I don't have an answer on how sports organizations could make their rules. But the rules need to be based on human biology, not artificial political categories, because it's human biology that determines performance, not human wishes for performance. Now, if you really wanted to get technical too, that was really the last bit that I wanted to say. But if you really wanted to get technical on this as well, you could bring in the event that she's competing in. Because like we mentioned, I mentioned testosterone builds muscle mass, right? Testosterone builds muscle mass. Muscle mass is typically good for quick events that require a tremendous amount of performance over a short amount of time. When you look at that in terms of running performance, that generally means you favor what are called fast twitch muscle fibers. You have 2 different kinds of obvious muscle fibers. One is called slow twitch and the other one is called fast twitch. Thank you, Matt. The reason I bring this up is because sprinters, if you look at a sprinter, you generally see somebody with big, huge, particularly sprinters. Bodybuilders are also one thing too, because like if you're going to do like, pushing up a big, huge weight, you don't do that for a long time, right? So sprinters, you'll generally see somebody with very large quadriceps, very large hamstrings, and very large gluteal muscles. So these are people with big legs and butts, okay? Big thighs and butts. Because they're going to go about 100 meters. And I'm talking like if you look at somebody like Usain Bolt, these big, huge legs, okay? They're going to go 100 meters. Generally your muscle fibers are capable of operating without changing metabolic processes for on the order of maybe 20 seconds max. So if you do 100 meters, you're probably using mostly fast twitch muscles. You're almost certainly using fast twitch muscles. 200 meters, starting maybe to need a little bit of endurance. By 400 meters, you're probably requiring slow twitch muscles. You're requiring some endurance type metabolic processes. Caster Semenya was doing the 800 meter. When you get down to just about a half a mile, you really truly require endurance. You can't pull that all off just with strength. You can't pull that all off with muscle mass. And here's the other thing too. The more muscle mass you have, generally the less efficiently you run at distance because you have to carry more muscle mass. So like Usain Bolt, he's I'm trying to remember exactly how he put it. There was but he said something about even just like 400 or 800, meter people. He's like, I can't believe that people run for 2 minutes at a time. So how can you possibly run for 2 minutes at a time? Because he's running for like, seconds, less than 10 seconds. So I don't know what the world record is. I forget now, but he's running for very short durations. On the other hand, for 800 meter, you're looking at around 2 minutes, at least in the women, in women's categories, 2 minutes or so, a little below now. If you're looking at a mile, right, we're looking at maybe 4 minutes. But then as you keep going up, like this endurance becomes more and more important. So anyway, where I'm going to go here is we could even look at just like 800 meters is considered middle distance, right? 800 meters, half a mile, middle distance. But there are longer distance runners, marathon runners. In fact, if you get up to maybe half marathon, by that point, even how do I want to put this? People assigned female at birth who even menstruate. How about that? So indicate that they have some vague semblance of an operational reproductive system, and even for that matter, menstruation isn't necessarily a perfect indication, but they generally end up with higher levels of testosterone, not because they are trying to build bigger or more muscle mass, but simply for recovery. Because like you run 100 miles, even 13 miles, 26 miles, 50 miles, 100 miles, you need to do a whole lot of recovery. And so women ultra distance runners tend to have much more testosterone in their blood, higher blood concentration of testosterone, to the point where it might even cause them to stop menstruating. Do we moan about these people? We don't. So once again, I'm going to point out it's human biology that's determining performance here, and not our human wishes on how performance ought to work. Matt makes the point he likes sprinters already with their big thighs and their big butts. Yeah. I always thought I would be a sprinter because I always thought I had I always had big thighs and butt, but I just don't build. I just don't have like strong muscles. Just don't have it. So anyway, so I'm about an hour into this. Look at that. I'm gonna take a break. I'm gonna go away for maybe like 2 minutes. In fact, I will leave it at 2 minutes. And after that, I'll be back, and I'm happy to take all kinds of questions if you got them. That's why I'm here. So let's do this. And we're back. I don't know. I enjoy saying something like that, like I'm David Letterman or something. But well, I'm sorry if that was a little boring. It was a little bit of biology there, a little bit of science. Oh, I'm looking a bit rumpled here, but that's fine. So Matt brings up the point. He cannot lie, and those other brothers can't deny. Yeah, that's what sprinters are all about. Yeah. Let's see. Right on time. Yeah. Well, I mean, I had the thing up. Like I'm watching the little thing. All I did was stand up and walk around my room. But so anyway, hopefully that wasn't boring. I do, the biology of all of that is very important. Again, I'm not going to say that I know all of the answers because I really don't. It's hard to say that we're doing the right thing. When you look at some of these classifications, Because obviously, we have classifications that we want to do. Uh, okay, Matt, I see you're about to go grill some burgers. Thanks so much. When you think about when you think about some of these changes that World Athletics has made, they're doing it because they're trying to go for a semblance of fairness, and I understand that. They want to appear that everybody has a chance. I mean, as much as a chance as you can, being you have to be an elite athlete in order to get there, right? I mean, this is already somewhat of a self-selecting kind of process. So I get that. I do get that. We want to keep using, those are politicians anyway, certainly want to keep using these some of these classifications, genetics, whatever it might be, because to do so means that they can regulate other things. They can keep you from going into the public restrooms in the Capitol building. All right. So, I get it that we want to make some classifications, but we definitely want to consider what it is we're trying to do. Why are we making these classifications? What do they do for us? Are they, do these classifications make things better or worse? So just since here I am, since I came back in, I'm going to do my station identification. I don't know if anybody remembers these. Does anybody remember like the Morse code? Doo, 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 doo. Anyway, station identification. I am Amethyst Eric. I talk about identity and gender, and today I'm talking about sports performance to a certain extent. And now we've gotten to a point where if you just have a question, I absolutely welcome it. I'd love you to ask me some questions about the transgender experience or, whatever else. In fact, ask me whatever else. And if I can't answer it, I'm just going to say, can't answer it. So these classifications are valuable. I think that there is value in them. And at the same time, we always want to question why we're making these classifications. Because if the purpose is purely just to discriminate against people, we're not doing a good thing. We're not doing a good thing. And unfortunately, a lot of the times we have people who don't know anything. They don't know anything about whether they don't know anything about the biology, but they go, well, I'm going to write a bill, to do this. I'm going to write a bill that's going to discriminate against certain people. Why, I don't know. But I mean, this has a long, there's a long history. If any of you remembers well, none of us remembers, but if you know the history of the Scopes monkey trial, the guy who ended up writing that, the guy who wrote that bill, introduced it in Tennessee that says evolution shall not be taught in Tennessee schools. Although kind of ironically, the Tennessee Board of Education also said, we want you to use this particular book for teaching science. And that was what the guy taught out of, right? That's what Scopes taught out of. Anyway, point here being that that guy ultimately, when they asked him, they said, why did you write this bill about evolution? And he goes, I don't even know. Like, I didn't know anything about evolution. I ended up learning about evolution after the fact. Somebody wanted to go after the bill, and I was like, oh dang, does that make a difference? Went and went and went and looked at the book and went, oh, I learned something today. Look at that. How about that? So yeah, Grief, you're right. There at this point I only see 6. There are Twitch people, could be I didn't mean to say a platform there, but it's a good point. I will say though, I mean, I have more comments, and I've been a little bit surprised, but anyway. So where was I going with that? Oh, sure. So we have politicians who don't necessarily know what it is they're even trying to regulate. And I'm not saying that's always a bad thing, right? Because I mean, I don't expect people, I don't expect politicians, I don't expect anybody, for that matter, to go and like pick up a book about human development, pick up a book about biochemistry. I don't expect everybody to go to school to learn about biology and sociology and psychology and biochemistry, all these, and nobody can know everything, right? I recognize that. But that's why I think it's important ultimately that if somebody tells you something, that you go and validate it. It's not that hard to go and validate certain things. In fact, Grief, you were the one who brought up Caster Semenya at some point. And you also used the phrase, you said that 5-alpha reductase type 2 deficiency was more prevalent in people who would be assigned male at birth. But the reason why it appears, at least appears that way, is because we don't generally notice it in women, because dihydrotestosterone isn't of much value to people assigned female at birth. And I don't think you made a bad point. I don't mean to say that it was a useless point, because it's not. But that is a statistic that you go, well, we see it more in people assigned male at birth. Yes, we do, because then it's noticeable. If it's not noticeable in a body, we don't notice it at all. And again, I mean, to bring up at least my own intersex condition characteristic, I would never have known until I started HRT and responded to estrogen therapy so well. So I mean, I don't know. So it's an important point that we consider, how we classify people, but it's also important that we think about why we want to do it. For the most part, what we're seeing, at least in politics today, we are not necessarily seeing people who have fairness on their mind, and I guess that it becomes the next question: what is fair? Fairness doesn't come from science. That's maybe the best way to put that. Fairness doesn't come from that. Biology has nothing to do with being fair. Biology only is. So Grief says these DSDs are more common in elite sports participants from the developing wild. Let me rephrase that. Those DSDs are more commonly observed in elite sports participants because it's there that it makes a difference. But we have these things occur all the time. I made a comment that 1 in 200, about 0.5%, the estimate right now is that about 0.5% of children born are born with at least one, saying, okay, at least one intersex characteristic. But we don't notice them. Usually we don't notice them. We don't notice them because they don't affect normal life. And I'm going to put that into quotes again. When you get to elite sports participants, yeah, we want to look at every single thing that they do. You've brought up Imane Khalif as well, and I have yet to see like complete, test results on any of that, other than one Russian organization saying, well, we think she has a DSD and we disqualified her. But of course, the IOC, the Olympic committee, not. So when you say they're more common in elite sports participants, really what you're saying is they're more easily observed because those people are under greater scrutiny. There are a very tiny number of elite sports participants out there. 8 billion people, but you have, I'm sure it's far less than 0.5% of people who are of 8 billion who are elite sports participants. So anyway, more easily observed. New Chan brings up, I think some of these athletes are weaponizing the issue to compensate for either their lack of training or to otherwise gain some sort of advantage. I mean, obviously there are cases recently, and I'm not going to name any names here. Simone Biles, of course, made a point to say, well, you're trying to compensate, just go train harder, right? And I think that ultimately is what brings up, the sense of fairness. Is it fair? Is it fair for somebody to come into um, a sports classification and have biochemistry that's different from other people? I don't know necessarily that. Uh, Grief, I'm seeing what you're saying here. Give me 1 second. But um, as far as compensating goes, uh, I don't know if that's the best way to put it. Um, does it feel fair when somebody comes in and conceivably has an advantage that you don't? Hard to say. It's a very difficult problem. Um, what we're trying to do now, just by like eliminating people, like perhaps Imane Khalif or Caster Semenya, just out of hand, is not the answer there, because now we are having transgender women starting to go into some of the women's sports. I notice nobody gives a crap when a transgender man. I mean, there's somebody does. I mean, there's a football team. Grief, maybe you can help me out on this, but there was a football team in Britain recently, I believe, who booted off a transgender man. Usually, people don't care because they're like, "Well, you started off already, below, so who cares?" But um, so grief says two factors: more consanguinity and less medical services. Less medical services. I'm curious what you mean by that. Um, and I'm curious what you mean in general, really. Um, two factors for what? Because I mean, we can't. I think if we investigated every single human, if we did not make the assumption that every human we see operates exactly the same way, I, I think we'd find much greater percentages of a whole lot of things, intersex characteristics, and maybe even things that would end up being classified as DSDs. Um, really, the problem is that we don't study them. We don't study them unless we really strictly have to. And I've made a point too. I mean, like if I went to, I have a friend. I've had a couple of friends actually who went to endocrinologists. Um, and they said, listen, I'm always tired. I'm gaining weight. I'm tired. I'm gaining weight, etc. And anyway, the endocrinologist takes a blood sample, says, well, you have low testosterone. What we're going to do is give you hormone replacement therapy, ultimately boost their testosterone. Now, if I had gone to an endocrinologist and said, hey, I feel terrible, I have chronic fatigue syndrome. I'm putting on weight. I'm not, my metabolism seems terrible. My digestion's terrible. An endocrinologist would have looked at my blood testosterone concentration and gone, yeah, you seem fine. Go back home. So it's like, you know, does that, I guess my point is he wouldn't have known. I have a some intersex characteristic, but an endocrinologist would have said, well, we've ruled this out. And that's because we go based on things that are, we make decisions not necessarily based on personal biochemistry, but we make them based on statistics. And that's what I will keep returning to. If you make decisions always based on statistics instead of the individual's biology, you're always going to be off, because no two humans operate the same. That's the way genetics works. That's the way biochemistry works. Yes, you could say, well, usually we see this, but usually is not the same as the way nature works. And so there's our problem there. Um, I appreciate your point here. Says I think it was Buck that said identities don't play sports, bodies do. I don't know if you mean Buck Angel. presumably. Truth, bodies do play sports. Um, but I've already brought up, like, at this point now, my testosterone level's really low, right? Because I don't actually have the parts that would have been able to generate testosterone in the first place. So I may go into a women's sporting organization, and if somebody says, "Well, you have an XY genotype, you are necessarily better," but if I wasn't able to build the muscle mass that I supposedly was going to be able to because of this XY genotype, and now I do not have the testosterone level, what's the difference? Yes, bodies play sports. So if bodies play sports, why are we regulating genetics? Why are we regulating uh, you know reductionist views of biochemistry? We should be thinking about the bodies themselves. So, all right, so Grief, you bring up Barbara Banda. So BBC Female Footballer of the Year, but previously banned for failing gender test. I'm curious what you mean by gender test. That's fascinating. No, that's the person I'm thinking of was on a team. It's a transgender man, and I don't know if Barbara Banda is what you're saying would have been the dead name. I don't know, um, but I am thinking about somebody who was who was playing men's football, and it might not have been professional for that matter. I don't really know. Let's see. Okay, so Grief says, "Oh, gotcha. Okay, less medical services. Understand what you're saying here. So when you mean that Africans are older when they find out because the medical system isn't as advanced." Well, I don't know. I'm gonna throw back out there. I was 52. I was 52 when I found out anything about an androgen insensitivity syndrome. Their medical system is different, certainly. Um, but that doesn't mean that an organism with an intersex characteristic is necessarily going to be different, is necessarily going to behave differently. So there you go. Anita makes a great point here. Anita Lichtenberg says, I want to throw in that my friend who is intersex objects to the term DSD. So Anita, I don't know how your friend displays an intersex characteristic. Um, differences in sex development was intended only to, I don't want to say only, is intended to apply to largely externally observable primary sex characteristics, which is a very small proportion, for what it's worth, of what we classify as intersex. So I don't know how your friend displays intersex characteristics. I kind of object to the term DSD too, because I think what it does is, it kind of diminishes what we're looking at here. The other thing too. Oh, hello, Luna. By the way, Luna just came in. But I also object to the term intersex, because intersex implies to a certain extent that biochemistry is necessarily classifiable by sex. But what we're doing, again, just to go back to it, what we're doing is still taking two classifications. We're saying, well, this is normally something that we see people assign male at birth doing. This is something we normally see people assign female at birth doing. But they're not doing that, so we'll call it intersex. But the thing is that the human genome, there's only one. I know I held up two fingers, but it was only for a moment. It was two number ones, right? There's only one human genome. Allosomes 1 through 22 are largely similar. I mean, 99%, which, when it comes to genetics, you go, oh, 99%. But I think I brought up, I don't know, it was a couple of weeks ago, I think, that humans also share 95% of our genome with cats. So, and I don't know if you've noticed, cats are generally pretty different. So, anyway, yeah. So I object to considering human biology as necessarily pathological. I actually had a conversation with a friend of mine yesterday. That's when it was. I don't remember when I'm going to publish this. I have a podcast that's going to come out. I think it's mid-August. I think it was about mid-August. But the reason we started talking in the first place is because she made a point as a psychologist. She made a point that we tend to give people a whole bunch of labels and then say, okay, go and handle these labels. But we tend to look at these labels in a reductionist fashion. So we go, oh, you have depression. Oh, you have anxiety. Oh, you have this. Oh, you have that. And her biggest point was that something like complex PTSD, which is not yet in a DSM, so presumably it'll be in DSM-6. I don't know when that's supposed to, when or if that's going to end up being written, but complex PTSD is not in DSM-5, not even the text revision. And as a result, there's no medical billing code. There's no diagnosis. And what that means is that you give somebody diagnoses that don't cover the entire condition. So anyway, just to go back to this, I don't even like the term intersex because it implies that human biology in some way can be wrong. And I don't think it can because it's just biology. So, all right, Anita says her friend's point is, sorry, my apologies, Anita, I think I misgendered you. Their point is, as they understand, that DSD is a term that has been introduced by doctors and mainly used to other people, whereas intersex is a term that many people use to self-identify. I mean, there are intersex has an actual genetic definition. I mean, it does have a biological definition. Now, there's no doubt there are people who will identify as intersex. I mean, I guess at this point, I would say that I don't know that I identify as intersex. Rather, I appear to display an intersex characteristic. But so I see what you're saying. DSD is something that's very, very focused on physicality. Very, very focused. Should say physical structure. Not necessarily operation, not necessarily functionality, but really strictly physical structure. You look at something and go, oh, that seems like a difference. Oh, really? Seems like a difference. I mean, some women have big boobs, some women have small boobs. Is that a difference in secondary sex development? So there's a very blurry line, in which you would call a difference in sex development, and really, because when Caster Semenya was born, this was 1991. Okay, just to point this out, this was 1991 in South Africa, so not like some real backwoods type place. Just to go back to Grief's point, which is still a good one, the idea that the medical system's less advanced, but still 1991 in South Africa. All right, I mean, a doctor looked and said, sure, assigned female at birth. Did not go, ooh, looks like a DSD. So, anyway, I think I'm objecting to everything. You know what? I object to my own objection. I don't know why, but it sounded good. So, I think the main point I want to make here, especially Anita, given everything you've said here, one of our major problems is that we have to make labels. Humans have to make labels. And we use these labels because it helps us regulate people. You don't want somebody who has some sort of a psychotic disorder doing such and such, babysitting your kids or something. Oh, see, now we've just stuck a label on something. And yet you can look around on just about any streaming platform, and there are people with schizoaffective disorder who live totally and completely like functional lives, and make videos to say, look, I'm living a functional life. So Our big point, the big problem, in my opinion, is ultimately labeling. Uh, if you need to self-identify with something, and I don't think there's anything necessarily wrong with self-identification of various things, because I will introduce myself as a transgender and pansexual woman. There's a self-identification, right? I mean, I've given myself labels, but in part I give myself labels because it helps other people. It's much easier just to tell somebody I'm transgender and pansexual and they go, "Oh yeah? Okay. Now I have a general idea of who you are." But they don't, do they? Oh my gosh, I think I just see the poet Miranda, which, hi Miranda, if you just came in. So right now Matt's saying he finds this objectifying. Absolutely. I object to your objectification. I object to your objection that this objectification has been objectifying it. Okay. There we go. There's Miranda. Hi Miranda. Um, so anyway, ooh, I don't know what the nope is. Yu Chan says nope. I give you. Oh, there we go. Yes, they see that and point fingers. Yeah. Well, I mean, this is, but people love that. People love being offended. That's kind of the thing. I mean, it's a funny bit. I think it's a funny bit that you have people out there and you just go, okay, well, look, here's the kind of person they are, and they go, you know what, I'm offended. And you go, I didn't even do anything. They go, I know, but I'm going to be offended. I am going to proactively be offended for whoever you seem to be. It's weird. It's weird, but I recognize there are people who go, well, listen, this is how I make it through life, by being offended. And I'm not trying to say that's on either one side, right? Because I mean, because you all the special snowflakes, conservatives go, well, look at all the special snowflakes out there. Typically, they're millennials, right? Every millennial out there, you must be a special snowflake. I'm going to be offended at you. They're going to be offended at baby boomers calling them special snowflakes, and I think kind of rightfully so. I'm not really sure why baby boomers wouldn't think that was offensive, but you know, you throw that out there and you go, well, there are certain people who just get offended. That's generally you get that from the conservatives. And then if you look on the liberal side, right? If you look at the liberal side, they go, well, hey, um, I'm offended that you could possibly like boys when you're a boy. I'm offended that you could possibly like girls when you're a girl. I am very, very offended at just about anything. I think that's kind of crazy. And Yu Chan even brings up, I think we should teach cultural appreciation in grade school. Cultural appreciation. I think that's an interesting point. I think it's a really interesting point. Oh, by the way, Slapstick Talk just joined. Hi, how you doing? Um, cultural is being transgender or pansexual. Is that culture? When we bring up cultural appreciation, like when I was a kid, cultural appreciation when I was in college. This was back in last millennium. So who knows? But cultural appreciation meant, well, we're gonna, because I grew up in Los Angeles, right? So they go, well, look, let's talk about Dia de los Muertos or something. Let's grab some Mexican some Mexican culture in some way. We're going to the hat dance, right? I learned the Mexican hat dance. I'm not even positive how much how much they do that in Mexico, but so. And I get what you're saying, and I like that. So New Chan says, well, my meaning was being tolerant of others. Totally agree. We what's crazy though, because here we go, going back to my grade school, I had a God, what the hell is it called? I'm okay, you're okay was the little catchphrase. There was something more to it. There was a bigger name for it, and I forget what the bigger name is. But I'm okay, you're okay. That was supposed to be the thing. And some of the things, like it was sort of a role playing thing where they'd act something out. You'd see somebody who go, well, I am this, 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 and this. And the other person would go, well, I'm the opposite of this, that, and the other. Well, I'm okay. Yeah, you're okay. And it's I don't did it do me much good? I don't know. Because I'll tell you, I would say that I spent so much of my life to a certain extent being offended. I'm looking around myself now, and it's like, well, now I feel more capable. Now I feel like I have the capability, and well, hang on, I'll get to that point. Now I feel I have the capability of of being more tolerant of others. But you know what made me more tolerant of others? I used to be I used to be the important person in the room, right? I was a white man in science and technology. I was the man. And it never was true. It never was. But it was certainly much easier than it is for me now. Now I have people who have who are very happy to discriminate against me, people who have made it their life's work, let's say, to discriminate against me, and so here we go. That made me suddenly go, huh? God, people sort of suck. Um, I don't know necessarily where I wanted to go with that, other than to say I read something on LinkedIn. This was some months ago, and it was directly after, maybe within a month of Donald Trump being inaugurated. And the person said, listen, the person said, this is a black woman, I believe in technology as well. And she said, I have people now telling me, geez, I'm sorry, I didn't, I recognize it. I recognize that there was this much um, discrimination, whatever. I didn't recognize it. And she said, don't bother. Tell me that you didn't care until it directly affected you. And as much, I mean, I'm saying there's a little bit of a heart-to-heart confession here. As much as it sort of pains me to say this, yeah, that's unfortunately what I did. I didn't care. And that sucks. Like, it sucks that I spent a lot of my life going, oh, well, other people will make it through. I don't like that. I would much prefer that I've lived my entire life being tolerant and not now being tolerant because I'm not being tolerated. I think that's a bummer. And the stupid thing is that I grew up being bullied, so it's not like it's not like I had a great childhood where everything he's like captain of the football team or captain or cheerleader squad. I mean I didn't even really have that. So anyway, being tolerant of others. Yeah, I wish we could teach that, but I don't know really exactly how well you teach it. That's the thing. I think you teach it when I think people learn that when they go, "Oh, I've lost all of my privileges." That's when people learn that. So, Miss Chief is here. Hi, Miss Chief. She says, "Hey, kitty cats." So New Chan says, "I guess it also comes down to human tribalism." Yeah, it does. Anyway, goes on to say, being afraid of what they don't understand. Yes, and haven't made any attempt to understand. I think so. Tribalism is a very, very powerful force. And I think I want to use that word, force. Like the gravitational force, the an electromagnetic force. It's it really does act as a human tribalism. The desire to fit in is very, very compelling, exceptionally compelling. Um, so Miranda also says it is their life's work, and that's sad. Yeah. Why would some people, that is all they've got? This, I'm going to bully you, and there you go. Miranda also says she was bullied as well, and had to get past the anger before she could pursue such ideals as tolerance. I really appreciate that, Miranda. Thank you for that. Um, we do get that, right? I mean, when I want to bring up, so in graduate school, I swear this is a point. I'm going to back into this a little bit differently. In graduate school, specifically when I was going to go and defend my dissertation, so my doctoral dissertation, there were I had professors. There were two professors in particular who just wanted to stick it to me. They just wanted to stick it to me. Why? Because their professors stuck it to them, or their graduate committee stuck it to them. We a lot of times we'll get into a situation, and because it was hard for us, we go, well, I want to make it hard for somebody else. And I think, Miranda, and maybe I'm wrong, maybe you can help me. Uh, Maybe if you're saying something different, help me understand. But I think that's part of the anger that we go, God, it was really horrible when I was growing up. It was just terrible. It was really bad, and that means that I am going to pass it on. What's that phrase? Hurt people, hurt people. I mean, I think it's part of what we see. And yeah, one of the big things is we have to get past this anger, but then we also have to get past this idea that if we don't fit in, that we're necessarily in trouble. Getting back to human tribalism there that Yuchan brings up. Um, so I love this. Anita says, I think I learned a lot of tolerance from my mom. My mom modeled not talking bad or excluding people who are immigrants, disabled, etc. The crazy thing is my parents didn't. My father was a very bigoted, racist person. I haven't spoken to my mother in a while now. There were times when my mother would say something that I would go, yeah. One thing in particular, and I'm okay sharing this story. My mother's still alive. I don't think she's going to watch this particular live stream, but I also don't want to dump on her too much. My mother at some point, um, so my mother was, how do I back into this? My mother used to work for somebody who was in Hollywood. Okay, just let me just get to that point. The point is, at some point, she met Siegfried and Roy. This was obviously some years ago, many years ago, because obviously they're not still performing. But she met Siegfried, and she met a lot of people. Tom Cruise was one. There, I got some funny stories, but point being that she met Siegfried and Roy, and I was talking to her on the phone, and she goes, "Do you know, gay people are just like other people. They just like the same sex." And I was like, "Yeah," because I'm like, I've been pansexual my whole life. By the time she told me that, I was probably out of graduate school when I had a few a few boyfriends. So she's like, "Yeah, they're just the same." And I'm like, "Huh." It's kind of like, how did you not recognize this to a certain extent, right? But my mother, so Niu Chan says, the core of the boomer back in my day mentality. Yeah, yeah, that's exactly what it is. In my day, this is what we believed. And that means it must be true, right? Niu Chan brings up a really interesting point too. There's also the current desire to whitewash history. They don't want to learn from it and end up repeating it instead. It's true. I mean, whitewash usually means try to pull the. Usually, it ends up as a racist sort of way of doing that, a colonialist and racist type thing. I get what you're saying, Yuchan, that we want to make history seem better than it was. We want to excuse the bad behavior and amplify the good behavior to say that, see, this is why we should keep doing it. Um, Grief Foundation says, Tom Cruise, Siegfried and Roy, your mom met all the gays. My mother at some point, I talked to her. This was for somebody who loved watching movies, it was a crazy, crazy thing. Oh, actually, before I tell this story, Miranda makes the point, nostalgia for a time that never existed. I think that is a beautiful way to put that. It was a time that never existed. But I think this is, when we say make America great again, nostalgia for what? What was that? But all right, so here's my story. All right, I'll try to make this quick. I call her up at some point. I don't know when this was. This was 20 years ago, I'm sure, at least 20 years ago. And she says, "Oh, I had lunch with a couple of really nice people today or yesterday, whatever. Had lunch with a couple of really nice girls." And I said, "Oh, really? That's cool." And she goes, "Yeah. Did you ever hear of somebody, Cameron Diaz, I think?" And I go, "Yeah, Cameron Diaz. Yeah, she's like an actress, blonde hair and bright blue eyes." And yeah, that's her. That's her. Oh my gosh, you ate lunch with Cameron Diaz? And she goes, "Yeah, and she brought a friend with her. I don't know, Lucy something." And I go, "Wait, Asian lady, Lucy Liu? And she goes, yeah, I guess. How do you know her? And I'm like, so there's this movie that just came out called Charlie's Angels. Like, look into it. So yeah, my mom has these stories that it's like, what? How did you even get there? But so New Chan says, I like this. I'm going to show this because I love this little I love this little feature too. A lot of people have forgotten the phrase, bring me, you're hungry, you're tired, you're sick, you're poor, you're huddled masses yearning. I think it's yearning to breathe free. Is it live free? I think it's breathe free. But yeah, the poem that's put at the bottom of the Statue of Liberty, right? That phrase is entitled is intended to say that the United States was a place where everybody would be welcome, that everybody would be tolerated, etc. And yet, I mean, I want to ask the question: do we ever remember the phrase? The way you put it was, we've forgotten the phrase, but I don't know how true that always was. If you look at particularly U.S. history, it's not clear that we've ever always cared about the huddled masses yearning to breathe free. Yeah, I think I'll leave it at that. This is an interesting point too. Matt Adlin says they've erased bi people from the Stonewall website. So I saw something about that. I did not. I didn't look into it much. I did see that somehow there had been an order that came down to take bisexual off. I don't even know why we care. Like, what, presumably there's something that they're going to try to do with it. But I guess I will just say this. And many people have already said this, so I'm just really repeating what they said. But if you allow the LGB without the T, they're just going to keep going backward. Sooner or later, they're going to go after another one. And if they go after bisexual, then maybe they're going to go after lesbians, and then they're going to go after gay men, and then they're going to go after the next villain. Villainization, vilification. This is the way a lot of our politics works, right? It's if you have a common enemy, you can unite people. It's a horrific idea, but there you go. Yu Chan makes a good point. Everyone's family history includes an immigrant at some point. Yeah, it's fascinating. We don't, it's interesting how I'm going to talk a little bit about evolution, although, this is not at all my field. But, we believe to a certain extent anyway, that Homo sapiens originated in jungles in Africa. And you'll get people who go, well, how come we don't have any fossils from that time? Well, because it's jungles. Actually, jungles tend to chew up everything. That's why we don't see some of these missing links, as they used to call it. So we believe that a lot of the belief comes from we had Homo sapien just in one place, but now there's starting to be evidence that Homo sapiens might have originated in a couple of places at once. Well, not at once, but when you're talking over the course of 500,000 years, like at once can be 1,000 years, right? So, but we're starting to see, well, how could we have history in South America that looks like this when there weren't like environmental, and I'm talking, like actual global environmental patterns that could have allowed people to have gone from Africa to South America within that amount of time. And Matt Anlin brings up, yeah, Savannah theory is currently the most popular. Yeah, there's a when you go back 500,000 years, it's tough to figure some of these things out. And then when we think about civilization, because like, do we care so much about a species, or do we care more about human civilization? Well, how do we define civilization? Right now, one of the big things they've used has been when agriculture started. So we're thinking maybe 30,000 years ago, 30 to 50,000 years ago. But agriculture. Why necessarily agriculture? people have used agriculture because it implies that you must have some sort of knowledge, right? That you must be able to figure it out. Um, Seasons, right? You have to have to figure out seasons. You have to figure out time to a certain extent. You have to figure out that you have seeds that you can stick in the ground. But some of this is like not ridiculously difficult, like relative to say language. you know, like language is is a pretty significant skill to develop, and we focus a lot on agriculture. But that would be the time that supposedly Homo sapiens stopped wandering, right? They stopped being hunters and gatherers and then sat in one place and went, we're just going to gather from this field over here. It's much less wandering. We like that. so so let's see. So Margie's here. Hi, Margie. Sleepy Kiwi reporting in. Let me see. Oh, wait, Matt says you literally wrote the Wikipedia article on the Savannah hypothesis. Look at you. All right, I'll go and read that then. Good on you. I think Grief Foundation ends up asking a very interesting question. Did humans coexist and have relations with Neanderthal? So Homo neanderthalensis and Homo sapiens are pretty similar, right? I mean, I think ultimately, and this is again just to talk about how statistics and genetics is kind of a weird thing, but the we sapiens appears to have shared somewhere on the order of 97-98% of our genome with Neanderthalensis. Did humans coexist and have relations with Neanderthal? Yes, our current belief is yes, that they certainly coexisted. There's a book, Daniel Lieberman is the author, and I don't remember exactly what the book's called, but he talks about how the way that humans, in for that matter, so sapiens and Neanderthalensis, the way that we were able to stand, that our diaphragm was disconnected from our movement. And so here's what I mean here. If you look at a cat, this is like in particular, cats are great. When they run, they tend to do something like this, and that operates like a bellows. So they will breathe in when they do this, right? And then they breathe out when they do this. So they are limited. They end up being limited by the amount of oxygen they can take in by the way their body moves. Homo sapiens and most hominins, technically, most hominins. Now, this isn't entirely true, but running like this, but then the diaphragm moves down. It's disconnected from the motion of the legs. So as a result, humans, the way that Daniel Lieberman puts it, humans were born to run, not in the Bruce Springsteen kind of way. Okay, just throwing that out there. But Neanderthals, because I actually did a whole article about Neanderthalensis, had a larger brain pan, thicker bones, bigger muscle mass, was in general, if you were to think about survival of the fittest, if you put that into your evolutionary theory, survival of the fittest, you would think Neanderthalensis was far better, far more equipped for the difficulties of living on Earth, especially if you're a hunter or a gatherer. Because hunters, Neanderthalensis should have destroyed sapiens for that. But the Earth was starting to warm up, some years ago. So, we've had ice ages, we have ice ages. There are several ice ages across the history of the Earth, some of which we don't even know why they occurred. So it's somewhat of an interesting point. But as the Earth entered a more temperate climate era, so there was evolution of animals toward being able to move more quickly. So you, instead of having mastodons, now you have antelopes. Neanderthalensis couldn't hunt because the things would just run away. Mastodons, they'd walk up to it and, what would be the I cannot think of the name of that guy. The Far Side, Gary Larson. What would be the like Og Hunt? Right? They could do that. On the other hand, very difficult to do that with antelopes. It was, ugh, dang. Well, ugh, hungry is about all we'd have. So, anyway, it's believed that humans, that Homo sapiens, uh, lasted because we were capable of running, because we were smaller. We were capable of being faster. That's about it. Neanderthalensis was likely better in every way. Probably a bigger brain pan, more intelligence, or supposedly more intelligence. So anyway, there you go. All right. Let's see. So I'm sorry. I didn't New Chan, I didn't mean to gloss over your point. You're saying in the grand scheme of things, yes, it does seem that the country has forgotten that phrase. If you look around right now, yeah, we're really clearly going, we don't want people, we don't want the poor, the huddled masses. We don't want the tired, the tempest torn. We don't want those people. We don't want them at all, clearly. So it's a good point. Let's see. The Fertile Crescent was a remarkable boon to the foundation of structured societies. Yeah, and the Fertile Crescent, so Mesopotamia, the land between the rivers, right? Um, again, there's starting to be evidence that shows that's not necessarily the first society. If you have Homo sapiens starting to develop in multiple places at once, little bit of a concern there. And the thing is too, uh, you know, structured societies. Again, what are we going to call that? The land between the rivers. You've mentioned Fertile Crescent, yeah, because we tend to think about things like agriculture as being the definition of civilization. But civilization, I mean, if you like, when you go to work or whatever, you have friends, you have a circle of friends. That circle of friends is a social environment, right? I mean, and that social environment uh, is a form of civilization. You're not necessarily doing agriculture, right? So, let me see. So I want to, because here's a little thing. Margie says, I've wondered if neurodiversity is connected with Neanderthal ancestry, while neurotypically is more of a Cro-Magnon trait. Well, um, so Cro-Magnon is if I remember correctly, predates both. I think Neanderthal was an evolution from it. But um, Matt's point, Neanderthal DNA is more common in Northern European ethnicities. Uh, truth, it's not remarkably simple to determine what we're looking at. When we look at DNA, it's very difficult to determine like what we're necessarily looking at. It's a I don't know how I want to put this. Um, we can look at particular genes and particular biochemical patterns more than anything, and use that to say, well, these two probably evolved from a similar parent, right? Um, I don't know how much Neanderthal DNA we've got sitting around. We can certainly say that there are genetic patterns common in several parts of the world. Um, I got to wonder. Anyway, Matt even wonders though, being of Northern European ethnicity on the spectrum. There you go. Wonder that himself. Princess Thistle is here. Hello, legacy content. Look at you. Oh, you're not late. I will admit though, I was I was going to shut down in a moment. We are kind of talking about DNA, but not really. Don't we share 70% of our DNA with an onion? I don't know the answer to that. I'm totally okay just saying I don't know. Oh, Cro-Magnon. Okay. So Matt is saying Cro-Magnon are pretty much the exact same species. The difference is we've got some degree of Neanderthal. So Cro-Magnon was a parallel to Neanderthalensis. Okay. Thank you. I didn't know the answer to that either. I don't know what the percentage is, but yes, for the most part, a lot of life shares similar metabolic processes. Plants obviously have different ones. Plants with photosynthesis are capable of creating sugars, but then almost all life uses the Krebs cycle to decompose sugars to burn sugars into usable into usable energy. So there you go. So Anita Lichtenberg says Cro-Magnon were the modern human immigrants to a Europe dominated by Neanderthals. Okay, so Matt says that's correct. I'm going to run with it. So parallel, okay. All right, it's 3:56. I am. Oh, look at you. So Matt says anthropology is one of his innumerable tisms. I'm curious, tisms. It sounds like a pathology. So let's see. It's almost 4 o'clock for me. I'm running on 2 hours here. I've decided, as I've mentioned, to start doing these to do these 2-hour streams because I don't know. There's just because if I do those, that means I don't have to make as many videos, which maybe you can just go, God, it's kind of lazy, Emmy. Yeah, it's true. But I'm going to do this again on I'm going to do this on on Tuesday. I'm going to do this again on Tuesday. I'll have a 2-hour stream again. And I want to point out anybody who's here. So if you're here and if you're interested, I like to bring somebody in on. I'm going to have 2 people coming in on Tuesday. Right now, I only have 1. So if you want to come into the Tuesday live stream, please reach out to me, purplepotclan.com or Discord or however you have me on, to connect with me. If you want to come on, you'll get 15 minutes of fame and you can tell me, we'll talk about whatever you want to talk about. So there you go. But before I go, I've got to. Can Neanderthals compete in Cro-Magnon sports? I don't think they can. The best thing is that we've now decided that they should not be able to, and that's the end. So Matt says, what time Tuesday? I'm sorry, I should have probably mentioned that. 5 p.m. Mountain time, so it'd be 7 o'clock your time, Matt. So yeah, I don't know if you're saying, do you want to pop by for a couple of minutes, but that'd be cool. So I don't remember everybody who showed up. I've got Casey, Anastasia, Angel, Miranda, Matt, and Thistle, and Margie, and Anita, and New Chan, New Chan, and Grief Foundation, Mischief, everybody here. Pretty soon I'm just going to say, hey, thanks, everybody. I should probably just do that, right? Just say, thanks, everybody. Matt, let's talk. I mean, if you're streaming for the first hour, I'd want to bring somebody in about 5:15 my time and then 6 o'clock or so for the next one. I could do 6:15 instead of anyway, we could talk if you want to come in. So that's it. Thank you so much. That's 2 hours. I'm going to say talk soon. And there you go. Bye.